Swayam Prabha. Digital India. Educated India.
Hello all, welcome back. We were discussing about different infiltration equations, that is estimation of infiltration. We have seen empirical equations and the corresponding numerical examples. So today we will move on to the theoretical equations. So many empirical equations are there, only 3 of the equations we have seen and some of the examples also solved related to Kostyakov equation and Hortense equation. Now let us move on to the theoretical equations. So mainly we are going to look at 2 equations, Phillips equation and Greenham's equation. So these are the analytical solutions for the flow equation. We have already seen the unsteady flow equation corresponding to the flow taking place in the unsaturated porous media, that is Richard's equation. Detailed derivation we have seen. So these are the theoretical equations, or the analytical solution is giving you the solution corresponding to the flow equation, that is based on the fundamental principles we are finding out the solution for the flow equation. So first we will see Phillips equation, then we will move on to Greenham's equation. Phillips equation is the solution for Richard's equation. Richard's equation is the flow which is representing the unsteady flow taking place through the unsaturated porous media. So Phillips equation is giving the solution to Richard's equation by making use of infinite series. So this is our Richard's equation. Del theta over del t is equal to del by del z of d del theta by del z plus k. This is a combination of continuity and momentum equations. Mass conservation equation and Darcy's law is taken for the representation of momentum equation, and combination of those 2 equations are done to get the final form of Richard's equation. And since infinite series is utilized, we need to go for truncation of the series. So truncation is carried out and it is found that accurate values of cumulative infiltration can be obtained from the first 2 terms. By considering the first 2 terms of the series, it was found that it is giving the accurate solution. In the Phillips equation, the assumption is k and d are functions of theta. In Hortense equation, it is assumed to be constant. We haven't discussed about that because it is an empirical equation. We have just seen the importance of the equation and the parameters of the equation while discussing about Hortense equation. In Phillips equation, k and d are considered as functions of theta. Theta is the moisture content. You know, whenever infiltration is taking place, theta is changing, that is the soil moisture content present in the soil is changing, because more and more water is infiltrating into the ground and the pores which are present in the soil will be filled with water. So the soil moisture present at the end of the infiltration or at the end of the rainfall process will not be the same which was present in the beginning. So k and d is equal to f of theta. K and d varies during the rainfall event. Hydraulic conductivity K and diffusivity D. In this particular equation, we have seen D and K, which represents the diffusivity and hydraulic conductivity of the soil. These 2 values are functions of moisture content theta. Now, the expression for cumulative infiltration is consisting of two terms. That is, I have already told you the truncation of the series is done for giving the accurate solution. So, the accurate solution for cumulative infiltration was found with initial two terms. So, f of t is given by st to the power of half plus k of t. So, two terms are present in Phillips equation representing the cumulative infiltration and also infiltration rate. So, cumulative infiltration is given by this particular equation. S is nothing but the sorptivity, that is, it is a function of soil suction, and K is the hydraulic conductivity. So, two terms you need to understand carefully, St to the power of half plus K of t. So, separately it is addressing two driving forces. The main forces which are causing the flow through unsaturated porous media is suction force and also gravity force, right. So, suction force will be predominant when it is in a drier state or it is in the unsaturated state. During unsaturated condition, relatively dry soil, suction force will be very high. That is, the first term will be predominant. St to the power of half is predominant during the time of unsaturated state. As more and more water is infiltrating, pores will get filled up with water and the effect of the suction force reduces and the main driving force will be gravity. So, that is represented by the second term K of t. So, this is our cumulative infiltration equation. For determining the infiltration rate, what we used to do, we will be differentiating the cumulative infiltration curve. This particular equation is differentiated. F of t can be obtained as 0.5 st to the power of minus half plus k. Now, you look at the equation as t tends to infinity. T tends to infinity means t is increasing. T starts from 0 to some time and t is increasing to a large value, then f of t, what will happen to the first term? 0.5 st to the power of minus half. So, 0.5 s divided by root of t. First term is having under root of t in the denominator. So, t is taking very high value means the value corresponding to the first term will be diminishing. So, f of t infiltration rate will be approaches to hydraulic conductivity. So, infiltration approaches K, it will lead to hydraulic conductivity. That is what I have explained in the previous slide. When the soil is in the unsaturated condition or in the relatively dry state, just after the rainfall starts, the pores will start getting filled up with water. Soil moisture will be increasing. So, initially the suction forces will be predominant, and as time passes, time increases to a certain value. The first term, influence of first term, from the equation itself it is very clear that it will be very slow. It will be approaching to, first term will be approaching to 0 and the total sum corresponding to infiltration rate will be hydraulic conductivity only. So, it will be at that time all the pores will be completely filled with water and the water will be flowing based on the action of gravity. Suction effects will be nullified at that time. So, two terms represent the effects of soil suction. Initially, suction forces will be predominant and gravity head. After long time, only gravity effect will be there. Suction effect will not be there because all the pores are completely filled with water. If you look at the equation, it is very clear that initially at a relatively dry state, suction force are predominant force behind the flow of water, and as time elapses, influence of suction diminishes and gravity effect will be coming into picture. In the case of horizontal soil, this equation, the advantage is that it can be utilized in the case of horizontal soil also. In the case of horizontal soil, the flow will be taking place due to suction effect only. There will not be any action of gravity taking place for the flow to take place. So, driving force is mainly soil suction in the case of horizontal soil column. we can write the cumulative infiltration f of t as St to the power of half. That is, we are having only the suction component, sorptivity term will be present, hydraulic conductivity term will not be present. So, you look at the equation again corresponding to cumulative infiltration, St to the power of half plus k of t. St to the power of half is representing the term corresponding to suction force and kT is representing the component corresponding to gravity force. So, if the horizontal column is present, flow is taking place through a horizontal column, the flow is mainly due to soil section. So, hydraulic conductivity component can be ignored, and that is why we are having the equation containing only single term. Now, let us solve one numerical example related to Phillips equation. A soil column has saturated hydraulic conductivity of 10 millimeter per hour and sorptivity of 35 millimeter per hour to the power of half. Using Phillips equation, generate infiltration curves. In this question, we are not given any value corresponding to cumulative infiltration or infiltration rate. In previous problems, you have been given the cumulative infiltration data. When we were solving Horton's equation or Kostyakov equation, we have been given the infiltration data. But here in this case, infiltration data is not given to us. We have been given the sorptivity value and also hydraulic conductivity value. We know the equation corresponding to Phillips equation corresponding to cumulative infiltration and also infiltration rate. By making use of these two values, that is sorptivity and hydraulic conductivity, and by making use of the equations corresponding to cumulative infiltration and infiltration rate, we can find out the infiltration rate curve and cumulative infiltration curve. So, the data given are the hydraulic conductivity K 10 millimeters per hour and sorptivity 35 millimeters per hour to the power of half. So, you need to be careful about the unit. So, the units are hydraulic conductivity is 10 millimeters per hour. Hydraulic conductivity unit is same as that of the rainfall intensity, and sorptivity is millimeters per hour to the power of half. We have to plot infiltration curves using Phillips equation. Infiltration curves means infiltration rate curve and also cumulative infiltration curve. The data given only related to sorptivity and hydraulic conductivity. So, we are going to assume the time starting from just greater than 0. That is, time in minutes we are taking, we are starting from 1 minute. Time is converted to hours, and we have been given the data corresponding to hydraulic conductivity and sorptivity. Our equation corresponding to cumulative infiltration is given by Phillips equation as f of t is equal to St to the power of half plus k of t. S is known to us, k is known to us, t we are assuming from 1 to 1200 minutes. After substituting for t for different time intervals, we can calculate cumulative infiltration as listed in this table. Cumulative infiltration in the units of millimeters are calculated and listed in this table. Now, corresponding to infiltration rate, this is the equation. Either we can calculate from the cumulative infiltration obtained, that is incremental depth we can calculate, and incremental time also can be calculated. Incremental depth divided by incremental time will be giving you the infiltration rate. And another way is that directly making use of the Phillips equation for infiltration rate. So, Phillips equation for infiltration rate is given by this, that we got by differentiating the cumulative infiltration equation. Small f of t is given by 0.5 St to the power of minus half plus k. So, here also S is known to us, k is known to us, and only t, as we have done in the calculation of cumulative infiltration. Here in this formula we will substitute for values corresponding to t, and it is calculated as listed in this column. Infiltration rate, this is in millimeters per hour. Infiltration rate is in millimeters per hour. Now, we can plot cumulative infiltration versus time, infiltration rate versus time. So, this is the curve. Along the y axis, primary y axis, this is our primary y-axis, infiltration rate is taken, and along the x-axis time is taken. And along the secondary y-axis, cumulative infiltration is taken, and the curve, that is the red curve, describes our infiltration rate calculated using the Phillips equation, and the green curve is representing the cumulative infiltration corresponding to the hydraulic conductivity K is equal to 10 millimeter per hour and sorptivity 35 millimeters per hour to the power of half. So, this way, by making use of the formula, you can calculate the cumulative infiltration and also infiltration rate. And sometimes infiltration rate and cumulative infiltration, any one of these will be given to you. From that you may have to calculate the Phillips parameters. So, that can also be done as we have done in the case of Horton and Kostyakov equations. So, I hope it is clear to you how the Phillips equation can be utilized for calculating cumulative infiltration and infiltration rate. Now, we can solve another example which can be utilized for finding out the Phillips parameters. What are the Phillips parameters? That is hydraulic conductivity and sorptivity. The question is, infiltration capacity data obtained from an infiltrometer are given in the following table. Determine the parameters of Phillips equation. So, the data given are shown in this table, time and cumulative infiltration. What we need to do? We need to find out the Phillips parameters, time in minutes and cumulative infiltration. And time is converted in hours. Time in hours is calculated and incremental time in hours is calculated as we have done in the case of previous couple of problems. And incremental depth, the data given to you is in millimeter, that is converted to centimeters. So, 9.8 will be 0.98, and the incremental depth in all the corresponding to each time is marked over here. Infiltration rate is marked in centimeters per hour, that is incremental depth divided by incremental time. So, that is given over here in this column. So, we are having the infiltration rate and cumulative infiltration is already given to us. Now, what we are going to do, question is to find out the Phillips parameters. Phillips equation for infiltration rate is given by this equation, that is f of t is equal to 0.5 st to the power of minus half plus k. So, this also if we are plotting, that is f of t versus t to the power of minus half, if you are plotting, it will be in the form of y is equal to mx plus c. X is nothing but t to the power of minus half. So, once straight line is fitted, we can get the values corresponding to slope and intercept. From the slope, you will get the value corresponding to sorptivity, and from the intercept, you will be getting the value corresponding to hydraulic conductivity. That is the reason why we have calculated infiltration rate over here. Cumulative infiltration is given to you. We have been asked to find out the Phillips parameters. So, for getting the Phillips parameters, we have calculated the infiltration rate. And what we are going to plot? We are going to plot between infiltration rate versus 1 by square root of t. So, this is the curve. Data points are marked, and with those data points, a straight line is fitted. Infiltration rate versus 1 by root of t graph is plotted. Those are data points are marked by the red dots, and the straight line which is passing through these data points is fitted, and that was having an equation 1.911 x plus 1.485. So, we can compare these two equations. This particular equation is written in the form of Phillips equation. F of t is equal to 1.911 t to the power of minus half plus 1.485. So, k is nothing but 1.485 and 0.5 s is nothing but 1.911. S can be calculated as 3.822 centimeters per r to the power of 0.5 and K is 1.45 centimeters per r. So, the units will be depending on our problem. In the question, what are the units you have taken, because this is an analytical solution, you do not have to worry about the units. So, the same units in which the data is there, based on that you will be getting the parameters also. So, it can be, if you are using the data in millimeters and time in minutes, the unit of hydraulic conductivity will be millimeters per minute. So, this way we can find out the parameters related to Phillips equation. So, now these are the parameters S and K. In the previous problem, S and K were given to us and we were asked to calculate the infiltration rate in cumulative infiltration, or we were asked to plot the infiltration curves. So, this S and K are the important parameters corresponding to Phillips equation. Once these S and K are known to us, we can make use of those values for calculating the infiltration taking place in that particular soil. So, these are the variety of problems related to it, and next equation is Greenamt equation. Next theoretical equation which we are going to discuss is Greenamt equation, that we will see in the next lecture, that will derive from the starting from the fundamental principles. It is a combination of continuity and momentum equation. Phillips made use of the Richards equation, and Richards equation solution is found out, and finally the equations have been given by making use of first two terms of the solution, infinite series. And in the case of Greenamt equation, we will start from continuity and momentum equation, that we will see in the next lecture. So, related to this Phillips equation also, you can get so many problems from these textbooks. So, here I am winding up this lecture. Thank you.